All right, so we're going to begin our unit on exponential functions. We're going to take a look at it in all kinds of situations, from a table into words, into equations, into graphs, and also into patterns. And of course, as always, as I do mine, you're doing yours. So as I figure out what my pattern is, you're doing yours. What is our 1? What's our 2? What's our 3? What's our 4? Can you then tell me what's our 5? And you can just use dots to make this easier. Can you also tell me what is our 0? So let's take a look at what's happening. In our 0, I have 3 bacteria. I don't even know if this is bacteria, but those of you in bio can help me out. I have 3 bacteria, and I'm going to go ahead and just circle it like this. So I'm going to say I have one group of 3. What happens in our 2? Instead of having one group of 3, I now have what? 2 groups of 3. Okay, so what happens in our 2? Instead of having 2 groups of 3, I now have 4 groups of 3. So my question to you is, what is going to happen in our 3? So pause the video real quick and see if you can draw it. And again, you can just use dots. So that's a group right there. Okay, you can use dots to represent the bacteria. Pause the video and see if you can do it. All right, so the pattern looks like it goes 1, then it becomes 2, then it becomes 4. So if it keeps following this pattern, it is doubling. So instead of me having 4, I'm now going to have 8. So there's the 4 from that, but I'm going to double it to 8. And if this pattern continues, what will be in our 4? Well, it's going to double from 8 to what? 16. And then in our 5, what is it going to do again? It's going to double. So the pattern in this exponential function is that it doubles each time. Okay, go ahead and pause the video and make sure that you figured out your pattern before we move on to the table. So each time we do a section, you're going to pause the video and then do the section with me as I do my example. So let's go ahead and fill out the table. So in our 0, I had how many? 3 bacteria, right? 3 little circles or whatever. In our 1, instead of having one group of 3, I have 2 groups of 3. And if you want to count them, you can. It's going to be 2 groups of 3, which is 6. In our 4, I have 4 groups of 3, where we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But it's just faster to go through multiplication. In our 3, I'm going to double what I have. So I go from 12 to 24. In our 4, I'm going to double what I have. So I go from 24 to 48. In our 5, I'm going to double 48. So that's 88, 96. Please pause the video and make sure that you've completed your table according to what's happening in your pattern. Okay, so what's happening every single time? I am doubling it. So what do I say? What do I say it is in words? Each time, each hour, I guess let's use what it says. Each hour, double the bacteria. All right, so just think about what's happening in the situation. So every hour, I go from whatever I have the one before, and I double it, and I double it, and I double it, and I double it, and so forth. So at this point, you've also paused the video and you've explained in words what's happening to your pattern each time. You're going to skip this for just right a second. We're going to come back to it. All right, so now that I have a table, let me go ahead and plot a graph. I will come back to an equation in just a second. So let's plot the graph. So at 0, and if you can't see this, this goes 0, 1, 2, 3, 4, 5. All right, so let's graph this at 0. So this is my x and this is my y. So when x is 0, so this is going to be hours in the bottom. When the hours are 0, I should be at 3. So this is 3 right here. And if you can't see, it's going up by 3. So this is 3, 6, 9, 12, and so forth. All right, so at 0, it's 3. At 1, it's 6. At 2, it's 12. So it's going to be right here. At 3, it's 24. At 4, it's 48, which is somewhere over here. And at 5, it's 96, which is, somewhere over there. So at this point, you should also have plotted hours versus the number of bacteria. Please do not join the curve. And why am I asking you not to join the curve? It comes down to this. Is it discrete or is it continuous? If you do not remember the difference, we're going to go ahead and talk about it right now. I'm not going to write it down, but you need to write it down. Discrete means that you cannot join the points, that they're discrete points on the graph. In other words, one goes with, I don't know, for example, 2. I'm not really sure what it is in this example. 1 goes with 2, then there's no 1.5, so then 2 goes with something else, and they're individual dots that don't join because you cannot have the in between 1.5. Continuous, on the other hand, means that it is continuously throughout the whole thing, meaning I can have every single value between the numbers, every single value here between the numbers. So go ahead and write those two definitions down just in case you don't remember the difference. And you're going to tell me, is your example discrete or continuous? In other words, can it only be 1, 2, 3, 4, 5, or can it be 1.5, 2.5, 3.5, etc.? Okay. So what do you notice about an exponential function? So
Draw what I'm about to draw on the top of the
an
page.
exponential function does this. It starts off really slow and then rapidly grows. Okay, that's what an exponential function does. And this is growth, right? The reason this is called growth is because it's increasing. Obviously, if it was doing this, and actually you can go ahead and draw it. So it decreases really rapidly, then kind of tapers off. This is called decay. So it's decreasing, right? So two things that we're going to look at is an exponential function growing or is it decay? Now that we have a graph, let's take a look at this equation. So equation wise, you can see that right off of a formula sheet. So you will get this formula as always. And we're going to look for it. So we're used to looking at y equals mx plus b, which is a straight line, which is linear. We're also used to seeing y equals ax squared plus bx plus c, which is the standard form for quadratic. We've also looked at vertex and factored. Now we're on exponential functions, so I'm looking for something with exponential functions, and right here it says exponential formulas. So I've got an exponential equation which says y equals abx. So I'm going to write that down so I can explain to you what that means. So y equals a parentheses b and then x, and we're going to go through what that is. Now, as you can see, just like y equals mx plus b or the quadratic one, they don't tell you what each thing is. You have to learn what each of those things are. Sometimes there's another letter here. We'll address that later. So right now we're going to say if there's nothing there, it's always 0. So our c is 0, but your a plus c is your y-intercept. Your a plus c. So if there's nothing there, then what is the y-intercept? Just your a. So a lot of times a is your y-intercept. The only time that changes is if they have another number after the parentheses. It's rare, but it does happen. All right, so your a is your y-intercept, or your a plus c is your y-intercept. Your b is your growth or your decay. How it is growing, growth or decay. So it's how it's growing, if it's going up, how it's decaying if it's going down. So at this point, you should have written down the definitions of what A, B, and C mean.
And you should be able to answer the two questions underneath from the equation. How can I identify start, initial, y-intercept, etc.?
And now we're going to apply it to your specific example. So I'm going to do my example. Please don't copy my numbers down for A, B, and C. Please copy it for yours. So I'm going to write the equation for what is happening in our pattern up here. Okay, so I have y equals, and then I need to find out what a is. So what's a? My y-intercept. And what's another thing for y-intercept for those of us who are not in a math class? If you're explaining it to your mom, for example, you would say where you start. So where did I start? I started at hour 0, and what was my starting number of bacteria? 3. So that's my start. All right, so my start is 3. Then I'm going to put parentheses, and the question is, how am I growing or decaying? How am I increasing or decreasing? So what happens from one step to the other? How am I growing and how am I decreasing? I am doubling. How do I say double in math? I say times 2. So I'm doubling is going to be times 2. And then x, and I forgot to label what x is. X is time. Okay. X is time. So that's just going to be what it is. So this is how you write the equation. So let's answer a couple of questions now that we know how to write our equation from a pattern. You can also write an equation from your table. You can write an equation from a graph, and I'm going to show you all of that in just a second. Let's just talk about where do you see the numbers from this equation, okay? And I'm just going to add a couple of things so you can answer this. So from here to here, what am I doing? Multiplying by 2. Here to here, multiply by 2. here to here, multiply by 2, here to here, multiply by 2, here to here, multiply by 2.
So again, what are you doing to get from one number to the next? What are you multiplying by to get to the very next number? So go ahead and write it for yours as well.
All right, so my question is, where do you see the numbers from the equation? So look right here. Okay, so looking at my equation right here, where do you see those numbers in this table? All right, so let's start with the number 3. Where do you see the number 3? Right here, right? And what can you tell me about that number? It's my y-intercept. So how do I find my y-intercept from a table? I go where x is equal to 0.
So again, you're writing down these notes as well for yourself because it says from a table, how can I identify my start, my initial, my y-intercept? So go ahead and write down, how do I identify from this table what my start, my initial, my y-intercept is right here.
X is equal to 0, y-intercept.
So again, you're going to also write down, how can you identify what your growth or decay factor is?
Okay. Where do I get this 2 from? So looking at my table, where do I get 2 from? Well, you can see I have 2's all over here, right? So true 2's are how it is growing. So it is my factor. If that's not something you're going to remember, we can write what you're multiplying by. So we can write B, and this is going to be equal to A. B is what multiplying each time. And that in math is called your factor. Okay, so my factor is times 2. And if you know that it's factored, that way we don't have to write what I'm multiplying each time, every single time.
Sometimes it's not as simple as, oh, it's multiplying by 2, multiplying by 2, multiplying by 2. You can't see it sometimes. So what you're going to also add here, and this is what I'm going to check when you bring your notebook, is I want you to write down, to find it, you're going to take the second y, so you can say y2 divided by y1. So in addition to what I wrote here, that you're just doing what you're multiplying by each time, and it's called factor in math. I also want you to write that is found by, so b is equal to y2 divided by y1. Okay, so wherever you have space after you've written that sentence out, you're going to copy this down because sometimes it's not as obvious.
So I get b from my factor, what I am multiplying each time to get the next number, and I get a from my y-intercept, which is when x is equal to 0. So that's where I get the numbers from this equation.
Now I'm going to do a different one here, but I want you to do f of 36 is equal to mean. And just to kind of remind you, now that you have an equation, you can put that equation into Desmos, make it into a table, and then either type 36 or press enter, enter, enter until you find what it's equal to. Once you find what it's equal to, you're going to tell me what it means in context. If you're not sure what it means in context, keep watching while I do my example. Do not copy my example down because it's not your question.
All right, now I'm going to look at another thing here. It says, I guess I should have answered this one first. What does 3 represent in the problem? All right, so now we got to write this in context. What does it represent in this problem? So I'm not going to say the y-intercept because what does that mean, right? So you always have to write it in the context of the problem. So it's my y-intercept. I know it's here. It's right here is my y-intercept when 0 and 3, but use these words to write it. So it is. And there's so many different ways, as we've previously discussed, that you can write this, but it is the amount of bacteria at the start, or the amount of bacteria at 0 time, the amount of bacteria when no time has passed. I think I like that one better. So what does it represent? The amount of bacteria when no time has passed.
As I explain my graph and where I get the numbers from, you're going to answer these 2 questions. How can I identify my start, my initial, my y? Then how can I identify my growth/decay factor?
All right, so where do you see the numbers in this equation? So I'm looking for these numbers 3, 2 now in the graph. So in other words, whether I was given a table or a graph, I need to know how to write this. And then I'm going to show you how to use a calculator as well. All right, so where do I see number 3? So I see number 3 right here. Right? So that's my y-intercept. So we know from the graph, I'm going to say A is y-intercept where it crosses the y-axis. Okay, this way you know wherever it crosses the y-axis, that's your A. So whether I'm looking at the table when it's x is 0, I know how to find A from both the table and the graph. All right, then where do I see this number 2? So this one's a little bit more tricky because it's not very obvious. But going off the table, I know I'm multiplying by 2 to get to the next number, right? So it is your, how am I going from here to here? All right, so we can see I'm going to go up 3, from 3 to 6 is 3, and then I'm going to run 1. Then I'm going to go, remember each one of these boxes is 3, goes up in 3. So this is going to be 3, 6, so it's going to go up 6 this time and still run 1. Then I'm going to go, this is 3, 6, 9, 12, and then I'm going to run how many? 1. So what's the pattern that I'm doing each time? And you can see, what am I doing? I am multiplying by 2. From 3 to 6 to 12, I am multiplying by 2. So from the graph, if you want to find the rate of change, okay, what you're going to do is take the second point and let's see, B. So B is going to be, take your second point, let me say Y, okay, then divide by your first point, both Y, on the Y values, okay? So I have, my second one is 6 divided by 3, and it works for any. So 6 divided by 3, or I could have done 12 divided by 6. And if you put all of that in the calculator, 6 divided by 3 is 2, 12 divided by 6 is still 2.
Now you should be able to, based on what you've just learned, answer example 2. So please go ahead and answer example 2 in regards to what's happening in this graph. This is the population in millions, and this is time in years.
Let's practice.